Good afternoon to all from the editorial board of BuildUp Portal. For the ones who are attending a BuildUp webinar for the first time, welcome. For our returning audience, thank you for renovating your interest. Just a brief explanation of what is BuildUp. BuildUp is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents one of the key sources of information on the topic of energy efficiency. You can register and become a member of the community. And you can also upload news, events, present a case study, results from a project, and so on. I would like to invite you all to navigate the portal. In the Learn section, you will find all the podcasts of the past webinars, so it is possible to listen to all the previous presentations. At the end of this webinar, the link to the full presentations and the file to the PDF presentation will be made available in this section of the portal. It is a pleasure to host today's fifth webinar of the EPB Standards series entitled EPB Standards Linked to Health and Wellbeing, which is organized in collaboration with the EPB Center and RIVA, Federation of European Heating, Ventilation and Air Conditioning Associations. As you can see from the screen, we have scheduled a series of webinars on the topic of EPB standards. Take a note about the next webinar, which will be the last one. It is taking place on the 8th of September at 12 and is entitled Heating System in the EPB Standards. I would like to invite you all to contribute and participate in this webinar. You can ask questions by typing in the box on the right side of the screen. They will be answered at the end, after the presentations. Now I would like to present the agenda of today's webinar and introduce the two panelists. First, Gerhard Zweifel, Professor Emeritus at Lucerne University of Applied Sciences and Arts and EPB expert, will discuss about thermal comfort and overheating. Then Dick van Dijk, EPB expert from the EPB Center, will explain energy needs calculation and ISO 52016-1 and thermal comfort. Finally, Gerhard Zweifel again will discuss about ventilative cooling and climate change by highlighting the current standardization work, completing the EPB standards. So now I would like to leave the floor to Gerhard Zweifel, and please, we can start the session.
Hello, everybody. I'm pleased to be invited to give this presentation here in this webinar on thermal comfort and overheating. Thank you for the invitation and also for the introduction. So I don't have to talk a lot about myself. You see my background here on the next slide. I have been an EPB Center expert since this EPB Center is in place, and I'm involved in many of the CEN working groups and technical committees, especially covering the area of ventilation and cooling, which is in CEN TC 156. I'm also working on the ISO level in some of the working groups active there. So what I'm going to show you is where in the set of EPB standards you can find information about indoor environment, about overheating, about conditions, what to comply with in terms of indoor environmental parameters, and that's shown here on the screen. You have seen this graph in previous webinars. I just added this particular standard here, which is EN 16798-1. This standard actually is the document to be consulted to get information about indoor environment parameters. I'm actually in the first presentation showing what the contents in that respect are of that standard. So the title of the standard you can see here, it's called Indoor Environmental Input Parameters for Design and Assessment of Energy Performance of Building. Addressing, and that's quite a wide area of topics, as you can see here, addressing indoor air quality, thermal environment, lighting, and acoustics. So this standard is actually, this number you may not be so familiar with yet, but it is actually the former EN 15251. So it's actually the same document revised. There is, as for all EPB standards, an accompanying technical report to this standard, which is sent TR 16798-2, which gives more explanatory information about the content of the standard. I'm going to talk about only part of the content of the standard because that's the topic of this webinar. I'm concentrating on thermal environment, and I'm not speaking about indoor air quality, lighting, and acoustics in this webinar. When you look at the content table of the standard, you see actually two main chapters. One is called design input parameters for the design of buildings and sizing of different types of systems, as you can read here. And you have another chapter on indoor environment parameters for energy calculation. The sub-chapters are mainly almost actually the same, except for one. The design chapter is giving information about noise, about acoustics, whereas the energy calculation chapter does not. There is, however, actually a lot of, it looks like they are two different chapters, but there is actually a lot of back reference from the second one here from chapter 7 on the indoor environment parameters for energy calculation back to the design input chapter. So in many places here, you find some reference to other chapters here in or other sections from chapter 6. There is one important set up in this standard. All the information, or almost all the information that is given in this standard is refers to this table with different categories of indoor environment quality. That's the abbreviation IEQ, stands for indoor environment quality. You have different levels which reflect different levels of expectation: high, medium, moderate, and low. In the text, actually, there are always only the numbers actually given here, these Roman numbers 1 to 4. And in the Annex A and Annex B, as you might be familiar with from earlier webinars, I mean, I can just shortly refer to that. We have in all EPB standards these Annexes A and B for national choices. I mean, Annex A is a template with empty information tables, and Annex B is the same annex, the same structure with filled-in parameters. So if there is no national, so Annex A is thought to be the template for national annexes. So actually, the method here is that national choices can be done via the national Annex NA on the assignment of data to the different categories. So this is also used in these annexes. In the standard, there is an additional source of information. Dick will refer to that in his presentation later on. For the energy calculations, which is actually nowhere referred in the in the text of the standard, but it is there as an important source of information, and that's the occupancy schedules. They include as well some parameters in respect of indoor environment quality, like temperature and humidity set points. So this is actually, this table is in the normative text, and it's not, cannot be changed in national acts, but it can be used for the definition of data. In respect of thermal environment, actually the text says that it shall be based on the thermal comfort indices, PMV and PPD. You might know about these indices. PMV is an abbreviation for predicted mean vote, as you can see here. PPD is an abbreviation for the predicted percentage of dissatisfied. The precise definition of these indices can be found in EN ISO 7730. It has been in place for a long time, and our standard here 16798-1 is just referring to that EN ISO standard. There are some parameters that go into this PMV and PPD indices about the occupant, and these two parameters are the activity of the occupant, called metabolic rate, so it's abbreviated to MET, and there is another one for the clothing, abbreviated to CLO, which can be, for instance, differentiated between winter and summertime and so forth. So these two things go into those indices. Based on the selected criteria, actually the standard focuses on the operative temperature. There is an interval given for each of the categories that we have seen before in the last slide. And one important thing is actually that the selection of the category is not necessarily being done for a whole building that is investigated, but can be done zone by zone or room by room, actually depending on what is going up in these parts of a building. So you can have an office and residential area and so forth, and you can assign different categories to the different uses within a building. There is also, and that's actually one of the main places, or even the almost the only place where we have like information in this standard referring to not only like comfort, but more information about health and well-being, and that's as an example, for special occupant groups such as elderly people, the standard says you might it shall be considered that you take it is recommended that you use category 1, so actually very as you can see here, very high levels of expectation, because these people have low metabolic rate and they are impaired control of the body temperature, so they cannot so easily adjust to the conditions that they experience. There is also a possibility to use the PMV PPD approach up here directly instead of operative temperature, but actually most of the information is based on this approach with the operative temperature. I didn't actually explain so much the operative temperature, which is again actually defined in other standards like EN ISO 7730. This standard also defines precisely what the operative temperature is. In short words, it is actually the mean of the air temperature and the mean radiant temperature that a body experiences from its radiant surroundings, like the walls around and so forth. But to be precise, actually precisely, it depends on even on the location where the occupant is in a room. It can be expressed for a certain location in a room. So as we see here for season, there is a differentiation between seasonal for the thermal environment for energy calculations. There is a differentiation between seasonal and monthly calculations and hourly calculations. It is said that for seasonal and monthly calculations, the same values as for design are to be used. So there is a back reference to the design values, where you can find a similar table for the design values with just one value in the table here, rather than the range that is given here for the assessment of hourly values. For hourly calculations, there is this target value given shall be specified, and there is there are default ranges here in this. This is one table, as you can see here, from the and also here from Annex B. So these are proposed or default values given in Annex B for acceptable ranges of the indoor operative temperature for certain types of buildings or building uses, and for the different categories, as you can see here. In addition, actually, there are methods for evaluating when you exceed actually those ranges that are given here in the CEN TR 16798-2, so in the accompanying technical report, which is not normative, but just additional information. Now, with the Annex A and Annex B approach, I talked already about, in Annex E, you have actually just this empty table, and this can be filled in a national annex with different values than are present in Annex B. So this is how this Annex A and Annex B works in this standard. Now, this information in the technical report, there are different possibilities, proposed indicators actually for the indoor environment. One is just to be applied also for longer calculation intervals. Actually, it's not true now, because here actually it says representative rooms for this simple indicator. That's one of the four. Representative rooms or spaces shall be simulated. So actually it says that the technical report says you have to simulate a room. That means also the hourly calculation method, according to EN ISO 52016-1, can be used for that as well, as we will see in Dick van Dijk's presentation just in a few minutes. Or there can be any other method which has undergone some validation. And then this simple indicator says, well, a building meets the criteria of a specific category if the rooms representing 95% of the building volume meet the criteria. So then you may have some rooms which don't, some 5% of the rooms which don't. Then you have other criteria, like this is quite straightforward. You just count the number of actual hours or the percentage of time when the criteria are met or not. there is an example given in Annex D of the technical report. So actually you take like these ranges here in the table, or the ones that you have defined on national level, and then you count when the number of hours, or calculate the percentage of time when, oh sorry, I'm clicking the wrong way. Then you calculate the number of hours or the percentage of time when these criteria are exceeded. You can also, there is another possibility, weight these exceeding hours by the temperature difference between the limit and the actual temperature of the hour. It's shown here in this column in the table. This can also be done when you do, rather than looking at the temperature, the operative temperature, you look directly at the PMV. Then the weighting factors are a little bit different, but it can also be done on this way. For both methods, there is also an example shown in Annex D of this technical report. So you have quite a choice, and it's all informative. It's not normative methods that are described here in this technical report, of course. There is, however, and that's quite important, and people are should be aware of this, for typical, actually with some limitations, actually I'm just talking about, there is the so-called adaptive method or adaptive comfort model that's also reflected in the standard. It is only applicable for occupants which sit at their activities, like in an office or in a residential use, which don't have strict clothing policies, so they can adjust their clothing. They can just take off a pullover or whatever, and so forth. And also they need to have direct access to things like windows with ventilation, flaps, and so forth, where they can by themselves influence their surroundings, the indoor conditions, and these conditions actually, only under these conditions actually this adaptive control comfort model is applicable. It is shown here in this graph, which is from the standard as well. For 3 different categories, you have a wider, like the solid lines, or a more narrow or even very narrow band, where the temperatures should actually lie in between, or may exceed the limit by some defined number of hours or whatever, as we have seen before. The graph shows actually this temperature limits as a function of this theta RM, which is called the outdoor running mean temperature. Is a little bit complicated. I'm not showing the formula. There is a formula given in the standard how this is calculated. So it's not an hourly outdoor temperature. It's a weighted mean temperature from a couple of days with different weighting factors. That's more or less how it is explained. So this adaptive may allow for higher temperatures with high outdoor temperatures, as we can see here. So it increases quite high up when you don't have very strict limits for a category with moderate requirements. But again, it's only under these conditions. If you don't fulfill these conditions, if you have a strict clothing policy, if you have no access to openable windows or similar things, you must not apply this model. And again, actually, the function which is given in Annex B, as we have seen before, this one, can be replaced by a different one in the national annex. So the Annex A template is empty. There are more criteria beyond actually only the operative temperature, like criteria for local thermal discomfort. These are draft risk. There is a criterion on radiant temperature asymmetry, vertical air temperature differences, and also the floor surface temperatures. Well, not all can be applied or calculated in our EPB standards. Some of them can. These are actually mentioned in the design chapter, so there is no reference to those in the energy calculation chapter. And as I said, not all can be are possible to be evaluated by the hourly method from EN ISO 52016. Some may, like the floor surface temperatures you should get out, radiant temperature asymmetry you might get out as well, but the other two normally you would not be able to calculate by this method. You would need another method, but they are also thought to be measured actually in the building. There is again a table in Annex B giving some values for all those 4 parameters, and again, of course, there is in table A, in Annex A, a table, an empty table just to fill in national choices for these parameters. There is also a possibility, especially for rather high operative temperatures above 25 degrees Celsius, that increased air velocity could be used to improve thermal comfort. So if you feel hot, it may be a release to have an increased air velocity by a fan that blows to your face or to your body. This is a possibility that's mentioned as well in the standard. You see again an Annex B table with some values, and again an Annex A table which is empty, where values can be put on a national basis. There is a hint here as well that above an airspeed of about 0.8 meters per second, loose papers on a table will start flying around. There is another issue, of course, besides the temperature, which affects thermal comfort or well-being, and that's humidity. There is, again, here in the energy calculation chapter, there is a back reference to the design and sizing values. And it gives just limits to what levels actually indoor air shall be dehumidified and humidified. But there is also it mentions also unoccupied buildings shall not be humidified. This is actually quite important because humidification is causing quite a high energy need. You see here again a table, an Annex B table with filled-in values for the different categories. And again, this is, of course, also can be defined on a national basis. With one exception, actually, and this down here, the absolute humidity shall always be limited to 12 grams per kilogram. So this is a limit which is not given free for national choice. It is in both Annex A and B it's mentioned here, and it's hardwired, if you wish. Just a last slide about the stage of this document. There are related ISO documents with the number 17772-1 and 2. They have not been developed in parallel. They have been developed in parallel, but not under the Vienna Agreement. That means they are not AEN ISO standards. In future, actually, it is planned to revise very soon, actually, the standard I have been talking about. Maybe it is under discussion that it will be divided in different parts because it has, as we have seen in the beginning, a pretty wide area of different chapters, and experts from different topical areas should be involved in this revision. The far end goal is most probably to have an EN ISO 52007-1. A proposal for that is in preparation in the respective ISO technical committees, and that's what we will see in on the long end. So in a few years, maybe we can expect that. The important thing is actually there is pretty soon will be some changes again on this standard. And that's, sorry, what I wanted to say about this standard. That ends my presentation. Thank you very much for your attention.
Good day to everyone. My name is Dick van Dijk, and my presentation is about the energy need calculation related to thermal comfort. So the energy need calculation is about one of these standards, the EN ISO 52016 Part 1, that was already mentioned a few times by Gerhard. My background can be found here on this slide. This is just for the record, and if you are interested, you can look it up in the recording later, which will be made available after this webinar. So I quickly move on to the content of my presentation. This is actually a slide you've also seen in the presentation of Gerhard. This is a simplified overview of the set of EPB standards, actually presenting the core set of standards. And here you find the EN ISO 52016 Part 1 as one of these core standards in the whole set. So here you see it with somewhat more detail. So you calculate the energy needs and the indoor temperature using EN ISO 52016 Part 1. And for this calculation, you need boundary conditions, like the indoor conditions that Gerhard already presented, also outdoor conditions, climatic conditions, and of course the component and product characteristics and the geometry of the building, etc. So I said one of the core EPB standards. And as one of the core standards, it provides a choice between a monthly or an hourly calculation. And that was the topic of the previous webinar. So I will not go into further detail on these two methods. My presentation will mainly be dealing with the hourly calculations, because that is the closest you can get to the thermal comfort information. Yeah, so that's presented in the previous webinar. As also mentioned in the previous webinar, there's a spreadsheet available at the EPB Center, so it's publicly available to run the monthly and the hourly calculation in parallel. So you use you fill in the input data, and they are valid for both the monthly and the calculation method. You can see both results of both the methods. as far as, of course, the output gives you all the information, because the monthly method, as you can imagine, gives you not the hourly results, only the monthly mean results. So that brings me to the next slide, and that is the conditions of use. So that's part of the input data that you need, or boundary conditions, so to say. So these have to be specified at national or regional level using the Annex A, Annex B approach, as Gerhard mentioned. So also this standard has an Annex A and Annex B for specifying the national choices. So concerning conditions of use, it means the occupant schedules, the temperature and humidity set points, and also, for instance, the internal heat and moisture loads by the occupants and the equipment in the space or the building. And these can be set for each hour and each day, so you're completely free at national level to specify these depending on the type of space or the type of building. So for instance, a standard office schedule or a standard residential building schedule. And Gerhard has shown that the default schedules are provided in EN 16798 Part 1. And might also be interesting to see the possibility to use these adaptive comfort criteria mentioned by Gerhard, to use these as an input when they are applicable. So because you're free to choose your criteria each hour and each day, you could also choose these ones as an input. So what are the links between EN ISO 5216 Part 1 and thermal comfort? So as I said, I will concentrate on the hourly calculation method. So it produces the indoor air temperature and the indoor mean radiant temperatures. And from that, you can calculate the operative temperature. And the operative temperature is, as Gerhard also showed, is one of the key indicators for thermal comfort. And at the same time, it gives you information about the actually quantified information about the level of under of overheating in your building. And I'll show some examples further on. It includes also latent heat load calculation, so the energy that's needed for humidification or dehumidification. And of course, in absence of a humidification or dehumidification system, it shows you the relative humidity in the space at each hour of the calculation, each hour of the year. Well, in addition to this normal hourly calculation, it also comprises, so the EN ISO 5216 Part 1 also comprises a mode for the design heating or cooling load calculation. So for the sizing of the system. And then you, of course, you use a different set of boundary conditions for the sizing of the system. And in addition to that, the standard can also be run in a system-specific mode. And that's what I will explain at the next slides. So EN ISO 5216 Part 1 contains actually a bridge from the energy needs of the system. So it's the calculation of the energy needs, but depending on the type of system and the design of the system and the type of controls, there is a strong or lesser interaction between the calculation of the energy needs and the calculation of the energy needs, the energy use calculated for the systems. So you actually need in several circumstances a feedback from the calculation of the energy use to the calculation of the energy needs. Well, and what has been done in EN ISO 5216 is to prepare for this interaction. And yeah, that's shown on this slide. So normally you would say, I calculated the energy needs, so I don't bother about the systems. I want the basic energy needs. Well, that's one of the options you can choose in your calculation. You can calculate the basic energy needs with default system parameters like obviously an infinite system size, an ideal control, and default recoverable system losses as heat load to your space. But in addition to that, the standard can also be run in a so-called system-specific mode. And in that case, you take into account the impact of, for instance, an undersized heating or cooling power and the recoverable system heat losses, so meaning the dissipated heat from system components that warm up the space are then taken into account. And an imperfect system control, so a control that leads to a temperature overshoot, for instance, or that leads to a too late response so that the temperatures don't reach the set point in time. So this is the so-called system-specific mode that can be used also in EN ISO 52016. And in my further presentation, I will concentrate on the undersized heating or cooling power. So I will focus on that by using a few examples. And the examples have been prepared using the spreadsheet, which, as I said, is available at the EPB Center. And the spreadsheet produces typical patterns like you see here. So just as an illustration, you see cooling load here, different at different days. You see the set point for cooling, which is not so strict at night when there's no occupation. This is typically for an office. It's more strict during the day, and then it's less strict during the weekend, and then during the working days it's more strict again. And here you see the air temperature and the mean radiant temperature in the building, and the operative temperature as the weighted mean of these two. And this is the kind of information that is calculated for each hour for the whole year, and this leads to the aggregated values for the whole year. So what we did is to select 4 cases, the same office space with a moderate climate, so the same case, with the only difference is the size of the heating and cooling system. So in this case, the size is adequate. And then we have 2 cases with undersized system. So in this case, a slightly undersized heating and cooling system. Here, a more severe undersized heating and cooling system. And here you find the extreme, which is the zero capacity of the system. So it's the system is absent. So obviously, if the system is absent, you have the lowest energy use because there's no energy used by the system. If you have a undersized system, you also have a lower energy use than the full-sized system. So if you take no other measures in your appreciation of what happens here, then you would say, well, the case with the lowest system capacity has the best energy performance. Well, as one of my colleagues at the EPB Center, Mr. Sokal, described it very strikingly. He says, well, so this means that the defect of the inadequate system becomes an advantage. And actually, that's not what you normally want to see. So now let's look at the results. So first, I concentrate on the heating part. So at the left side, you see heating load duration curves, but I have to admit that these curves are not so revealing if you have just a few seconds to look at it, especially because they use a relative scale for the maximum heating power, and then you see the heating power frequency for in this case, the month January. But you see here the different levels of the maximum heating power that has been used, with on top of it not mentioned the zero heating power for in the case the system is absent. And then here to the right side, it's more illustrating. It's the number of hours which the operative temperature exceeding the certain threshold, so to the lower side. So for instance, here you see in the case of absence of a system that during almost no more than 900 hours, the temperature, indoor temperature, operative temperature is less than 14 degrees. And I should stress that in this case, only the hours are counted with the required high comfort level. So not the hours in the office during the evening and night, and also not the hours during the weekend. So only the hours with required high comfort level. So, and also with the undersized system, you see that you have quite a number of hours that the temperature doesn't meet the set point, which in this case is around 20 degrees. So now move on to the cooling part. Similarly, let's look at the right-hand side, the number of hours of temperatures exceeding a certain level. So for instance, in absence of a system, of a cooling system, you have almost 900 hours with temperature exceeding the set point of 26 degrees. And again, only counting the hours with the required high comfort level. So if we focus a little bit on the case with the zero system capacity, so in case of the absence of the system, so how could we keep a level playing field between buildings where some of all of the occupied spaces have no heating or no cooling, which leads to low energy use but a bad thermal comfort, versus buildings or spaces which are adequately heated and cooled, which have the penalty of a higher energy use, but they have adequate thermal comfort. Well, there are different combinations possible in the national or regional building regulations to deal with this. I'll come back to that on the next slide, but one of the often applied principles is to use a fictitious system, which means that you assume that even if there is no system, so for instance, no cooling system, you assume that there is a fictitious cooling system and you assume that it has a conservative efficiency. So this would be, the efficiency value would be set as a national value then in your standards, instead of the absence of a system. So that means that the energy performance is calculated as if the space is adequately heated and cooled. And this works specifically quite well if you may assume that in this building or in this space, at a later use phase of the building, there will be an adequate system be added to such a space. And then you already anticipate actually to such kind of system. So did I need to say more about this? No, I'll go to the next slide, and that yes, that shows the different combinations which I mentioned before that are possible. So the fictitious system mentioned on the previous slide is one of the possibilities. The other possibility is to again use a fictitious system, but only if it really has an impact on the thermal comfort. So if there are really problems with the thermal comfort, then you could have a kind of a weighting influence of the fictitious system on your overall energy performance. Another option is to have no fictitious system, so simply do the calculation without the heating system or without the cooling system, but to perform a separate comfort analysis. And the comfort analysis could lead to a comfort indicator, and could also be that at the national or regional level, you decide to have a requirement on the comfort level. And Gerhard showed several ways to specify these kind of comfort requirements. And a last option is to have a different energy performance requirement in absence of a system. So for instance, imagine an office building without a cooling system. It will naturally use less energy than a same office building with a cooling system. And this could lead to a lower requirement for the energy use, which means a lower maximum allowed energy use in the energy performance requirements. So you have a lower requirement, and so it's more tough to meet if you have no mechanical cooling in the building. So that's another way to deal with it. These options are described in the post-processing EPB standard. So that's the EN ISO 52003 part 1 and 018 part 1, which you can trace back on the second slide of the presentation, and specifically in the accompanying technical report mentioned here, you find more details on this. And the conclusion is that from all this is that the temperature distribution calculated with EN ISO 5216 part 1, but also relative humidity are important outputs from the standard, and they can be used in these post-processing standards, which describe the choices you have at national or regional level for overall indicators and for the requirements. Now, before I conclude my presentation, I see the 20 minutes are now past, so we'll be quick. So a new standard is in preparation which complements EN ISO 5216 part 1, specifically to deal with adaptive facade elements. So this standard in preparation will enable to calculate the impact of a smart use of adaptive facade elements to get a better comfort and lower energy use. In the standard, default control strategies will be built in for a fair comparison between products, or a tailored control strategy can be introduced as an added value for specific technologies. And then finally, there is work in preparation on ventilated cooling, which is linked to which has links with energy needs calculation and the ventilation standards. That will be dealt with in the next presentation by Gerhard. So I will just conclude my presentation that EN ISO 5216 part 1 is one of the key standards, contains both a monthly hourly calculation method, and if it is applied in a system-specific mode, it shows the effect of an underside system on the indoor temperature, can be used as a quantitative impression of the resulting discomfort. This can be used in one or the other way in the regulations to avoid that an undersized system becomes an advantage in the calculated energy performance. And there are new initiatives that continue the work to complete the set of EPB standards, in this case to get the impact of more dynamic technologies on the energy and comfort standardized. So this concludes my presentation, and I like to give back the floor to Gerhard for his second presentation.
So hello again, it's me again, sorry about that. In my second presentation, I would like to show a few things that are currently underway, current standardization work, which are supposed to be complementing the EPB standard. So it's, part of the information that I give is already in the current standard, but there is more work going on, which I will show. And I will, you've seen that. I will start with ventilative cooling. And of course, when you talk about ventilative cooling, you have to be clear about what is meant by ventilative cooling. And that's already shows already that there is a need for standardization, because there might be different interpretation of that expression. And it's just my words as I put here. There is no official definition about that. I define it this way: ventilative cooling is the cooling of buildings or zones in buildings by means of cooler outdoor air brought in on national, hybrid, or mechanical ways. And if you use the term hybrid, you have to explain what that means. Again, hybrid means a partly involvement, be it timely or be it locally, of mechanical elements in combination with natural forces. So these two can be combined in any way. So this is actually what I'm referring to when I'm talking about ventilative cooling. Now let's start with the current situation on ventilative cooling in the EPB standards. There are 3 existing documents where there is some bits and pieces of information relative to ventilative cooling, or that can be used for the evaluation of ventilative cooling. One is the standard EN 16798-7, which is actually the calculation methods for the determination of airflow rates in buildings, including infiltration. And it has, of course, an accompanying technical report. I consider these two as one. There is just a little bit of additional information in this technical report to that standard. I'm just going to show what the content is. But first, let me talk about the third document. That's this, again, technical report, which is actually accompanying the standard 16798-9, the general part of the cooling standards. And in this technical report, there is some information about ventilative cooling. I will show that in detail just later on in my presentation. Now in EN 16798-7, the relevant contents here are, it has some methods for the calculation of airflow rates, for instance, entering and leaving through open windows, which is also applicable, of course, not only on windows, but also leakages, vents, any opening actually, which can be used to apply natural ventilation to a building or a zone. Also actually airflow rates for passive and hybrid ducts, which includes a little bit more of technical issues. That's also included in the standard. It considers these calculation methods considered some boundary conditions as driving forces, such as pressure difference due to temperature difference, the so-called stack effect, but also wind pressure, for instance. But there is no explicit application in the standards to ventilative cooling. Just the technical report gives some general hints on the application to ventilative cooling, but not really in detail, and the standard doesn't talk about this issue. It just gives these calculation methods, but these are important parts, of course, for the calculation of ventilative cooling. Now in CEN-TR 16798-10, there is a small chapter on ventilative cooling, and it is showing that, I will just show the graph, which illustrates what is written here, that given the modular structure of the EPB standards, it is not possible to be covered in just one single standard, and is also not a topic to be dealt with in just one technical committee, because it involves the calculation of airflow rates, as we just have seen. It involves the calculation of the cooling needs, as we have seen in Dick's presentation. These need to be coupled by a control scheme, and there are further data and element descriptions involved. And this is shown in this graph. It looks frighteningly complicated, this graph. I intentionally took it as it is from the technical report. So I didn't change anything in this slide here. I will change it a little bit. But you can see actually, this is an information that's given in this technical report. It looks, could be, well, Dick was referring to it as a little bit pessimistic, and that's true, but it just shows a comprehensive set of modules and signals that go from and to the different modules to others. Shows that it's not really so straightforward and simple. I would change the graph a little bit. Of course, the climatic data that we see here go also directly to the calculation of the building needs. And what actually goes from the occupancy and operating conditions to the control is actually the set points. And what I have added here, which was not in the initial graph, is actually the post-processing. So what you get out of the building needs calculation, you compare with acceptable temperature range, and you make a thermal environment evaluation out of that. So this is actually what you have to do. But I'll go a little bit more in detail in the next slide. Actually, yes, it looks pretty complicated. When I now compare it to a normal technical system, like a cooling system, it doesn't look so different, actually. I mean, what we have here is actually the controller goes to a technical system. For instance, a cooling system gives a signal, and the cooling system is actually extracting heat from the building or the zone. And the difference to the ventilative cooling is not so big. The main difference is actually that here we have actually this heat transfer by some airflows that first have to be calculated. So here I would like to just highlight the different informations that flow from these modules. It is a bit complicated, I have to admit. So what we have here actually from this is actually, let me first go to that slide. This is actually the standard that we have just seen in the first presentation. This here is actually the standard that we have seen in Dick's second presentation today. And this standard here about the airflow calculations is just, I have just talked about in this presentation 2 slides ago. And this is actually our control or building automation standard 15232, or now it is actually replaced by an ISO 52120-1. There is some climatic data also. There is some standard about those. So you see all those modules are covered by some standards in the EPB set of standards. Going back to what information flows from one to the other, and that's of course going out here from the requirements on the thermal environment. There is the temperature set points that go to the control, and the occupancy schedules that go to the building needs calculation. Of course, the climatic data are used in different places, like here in the building energy needs, also in the controller, and also in the calculation of the airflow. Of course, you have to describe somehow the building. That goes actually here as well, and even especially the opening description, of course. What can be opened in your object? To what extent can it be opened, and so forth. These things have to go in here in this calculation. And then you get out some flow rates, and along with the airflows, also the temperatures of those airflows. And you can calculate some heat transfer through that, and this actually finally goes up here as a contribution to the building energy needs calculation. And at the end, you can have, because you get the acceptable temperature range here, you can have your post-processing, your evaluation of the thermal environment. So yes, it looks complicated, but it's more or less straightforward. Perhaps a word to the control. Actually, these control things, actually, they are mostly included either in the technical system standards, or even you can include it here. But there is some information as well in this module M10-12 standard. So in this one. Dick has already announced that this will be shown again. This graph here, this is actually also a result which has been presented in the last webinar already, just comparing the indoor temperature that we see up here and also the mechanical cooling load that we see down here for two cases calculated with the 52016-1 method. In one case with a mechanical cooling, but without the ventilative cooling. And here in the other case with mechanical cooling plus ventilative cooling. So from that, you can see that these techniques can, of course, also be combined. And you see some decrease in the mechanical cooling demand here, less time where it has to be activated. And at the same time, you have some decrease in the indoor temperature as well, which is pretty much higher here in that case. So this is just an example how this can be done. And in the background, actually, the method is somewhat like shown in the graphs before. So now what this is just still the current situation, but there is I announced that I will talk about things that are under development and complementing our EPB standards. And there are two what we call preliminary work items in SEN underway. One is on and both are not standards but technical specifications. This type of document is a little bit less has less of a normative character than standard. But still it's more than just a technical report. One is on natural and hybrid ventilation systems in non-residential buildings, and the other one is on ventilative cooling, on the topic I've been talking about. So these are underway. It's work in progress. I cannot show a lot of content about those. Since they are preliminary work items, there is no time limit yet. So they have will have to give a signal when they are ready in these groups. And then the clock will start running, but we don't know any dates yet when this is going to happen. Just as an example, from the technical specification on the draft on natural and hybrid ventilation systems, is just like a categorization, a systematic of the different types of ventilation system typology. This is the type of information that we will find finally in this document. And in the other one, just as an example, there are illustrated principles of ventilative cooling, such as cross ventilation, such as single-sided ventilation, stack ventilation, and so forth. This is just an freely chosen example of content. There is more of that to be, which will be in this document. And mechanical ventilation can be, for instance, only mechanical exhaust or only mechanical supply and exhaust and so forth. So you can do, and have not been talking about that so far, but you can do a ventilative cooling, of course, also by just purely operating your mechanical ventilation system. So to conclude, for the evaluation of the effect of ventilative cooling, an hourly calculation method, I think that we have seen quite clearly from Dick's presentation and also from what I have shown here in the recent minutes. You need an hourly calculation method. Even if you would like to do that in a monthly or seasonal calculation, you would first have to do some statistical analysis of your hourly climatic data. You would have to do an analysis on select, and that will be only valid for the selected climate and the selected boundary conditions and so forth. So you would end up with an extensive table work, and that actually leads to the conclusion that the direct application of an hourly calculation is, for this purpose, much simpler than just doing this whole work beforehand. Now, let me come for the last few minutes to the second issue that is underway to complement the EPB standards. We have some development underway in respect of climate change. There is this EN ISO 15927 family 6 standards about how to generate different types of climatic data and so forth. There are no data in these standards, but procedures, how to produce this data. Many countries have generated data on the basis of these standards. And there is one, actually, part 4 of this group on hourly data for assessing the annual energy use of heating and cooling. And that's actually the standard where you have to follow the procedure when you produce climatic data, for instance, for the EN 52016-1 calculation or other simulations, of course. I'm not going into detail that it has some statistical method in place where you need at least data, hourly data from a series of measured years, like 10 years or more, 20, 30. And the analysis, the statistics that is described is based on some key parameters like temperature, solar radiation, humidity, and in the second priority, wind velocity. So that's what we have. This is the current situation. Now, what is underway is this standard is currently under revision. It has just started this year. And the goal of this revision is actually to include also future climate development. It is initiated and supported by the Adaptation to Climate Change Coordination Group, and the whole activities around climate change are also mandated by the European Union. The work started in this ISO TCM working group. So we have actually, it was planned to have CENLI because it is a European initiative, but this was not accepted. So it is running in ISO. There are first vague proposals for the methodology. And there's one big open question. In different countries, we have different situations about what is already available as future climate data. In many cases, there are actually only data available in a daily resolution, not in an hourly resolution, and that will be that is still an open question, how to generate hourly data sets from these scenario models when they are only available in the daily resolution. This is one of the big obstacles that we have to overcome in this development. So this has just started. It's not very far yet, but it will be, of course, an important contribution in future. Climate change will strongly influence the results, of course, of building energy and load and thermal comfort and so forth calculations. It will not have a direct influence on the calculation methods as such. This is the physics is still the same. When we take the example of the ventilative cooling, also climate change will not influence the strategies and their calculation, but it will shift the boundaries of effectiveness of those measures, of course. So what we conclude about from that is actually that both the calculation methods and the data are important. So this concludes actually my presentation, and I again thank you very much for your attention, and I guess we are now ready for the question and answers part of this webinar. Thank you.
Thank you both for your presentations. And yes, we can start the Q&A with the first question. How many European countries have made and published their own Appendix A for national values? Anyone can answer.
Yes, here's Dick van Dijk speaking. Actually, at the EPB Center, we are trying to make an overview of the countries that made their annexes within the context of their obligation under the EPBD to report their national methods in terms of the national annexes of the 5 core EPB standards as we presented also today. We know that several countries have a delay. They were supposed to report on the 10th of March, but several countries have some delay, and moreover, they are obliged to report it to the European Commission, and they are not obliged to publish their report at the moment. So what we have as information is just scarce information, is limited information and not always up to date, and we are working hard to try to convince the responsible persons in the countries and also to inquire at the European Commission about the status of these national annexes. And then, of course, it's not one national annex, it's a national annex of these 5 core standards, but we are also interested in the national annexes of the other EPB standards, and in particular because for the further development of the standards, it would be good to know, to get feedback from these national annexes for where the countries have made exceptions and chosen their national option instead of the options given in the EPB standards, because that could lead to an improvement of the standards and a wider use in the near future. So I'm sorry that I don't have concrete numbers at this moment, but as soon as we have more concrete numbers, we will also publish it on the EPB Center website.
Thank you. Second question. I have understood that this standard is being revised or planned to be. Is that correct?
Which standard is it referring to?
That's a good question.
Well, yeah. Well, if the question refers to EN ISO 52016 Part 1, then I can say that the standard is one of the widest used standards of the EPB set, and from the practical use we received comments on some errata that are in the equation. Some are obvious and some maybe less obvious. So we are collecting all these comments and requests for clarifications. So the first step that we intend to do is to publish the suspected errata and the possible solutions at the EPB Center website. So just as informal information. We did, by the way, the same for the overarching standard. You can find the document at the website for the EN ISO 52000 Part 1. So for this standard, we intend to do the same, and then depending on, and then this will be discussed, of course, in the relevant ISO and CEN working groups to come to the conclusion whether we need an amendment of the standard or a complete revision of the standard. Having said that, there's also a part 5 of the standard under preparation. That work just started, and that is to not to change or revise the standard part 1, but to give other further options to deviate from the prescribed equations in the standard, to use equations that are alternative equations that are also used in building simulation tools, to bridge further the gap between this standard and the building simulation tools.
Maybe the question, sorry, maybe the question was related to EN 16798-1. And I was talking about a planned revision of this standard. Yes, the work on this has not officially started yet. There are discussions around that plan in different technical committees and so forth. And actually the intention of the, like, say, the expert that has developed the standard, Bjarne Olesen, is really to start as soon as possible a revision. That's I don't know whether it will affect so much the thermal environment as we have seen. I don't think so. There are more like informations in the standard in other areas that are more subject to discussions. But there's no official schedule, no official work item yet, but it is the intention, yes, to revise it.
Okay, thank you. Another question, this is for Gerard. About the definition of hybrid ventilative cooling, potentially including mechanical means. Associating small size cooling batteries to the ventilation system would be excluded for this definition, and it becomes then a conventional refrigeration cooling?
Good question. I would say that the answer is not, for the moment, is not definitely given. But I would say it is rather what you ask in the question, that it is more considered mechanical cooling. Depends actually on the source that is connected to the battery in the ventilation system, and if that's some sort of free cooling, as you could call it, then it could be considered. Well, I wouldn't include it in ventilative cooling in that case anymore, but it is some other sort of like free cooling by technical means without involving a refrigeration machine. Maybe that's not a clear but a possible answer.
Thank you. There is another question. When will the European software based on the EPB standards be available?
Dick, do you want to answer?
Yes, well, yeah, as we also had the discussion in the previous webinars, the questions about this. As you know, that there is no common software available at this moment for the whole set of EPB standards. So what we have is spreadsheets on the standards for the individual standards, but then they are not simply connectable to each other. They are mainly used for demonstration and validation of the standards. So there are indeed discussions how could we come to an initiative to build a kind of a core software tool for covering all the EPB standards, and that is a discussion with stakeholders and also involve the European Commission, but that has not led to a conclusion to next steps yet. But of course,
Okay.
there are countries who have developed software tools for the standards or for the national version of the standards. So this is also an area in which we could look that to combine forces in one way or another.
Okay. One more question for Dick. In case of a fictitious cooling system in the building regulations, how can you reward, for example, ventilative cooling systems?
Well, if you have in your country the principle of a fictitious cooling system, then I would say that, assuming that you have calculation rules to calculate the effect of ventilative cooling, of course, then that you would give priority to the ventilative cooling in your calculation, and then you could have additionally mechanical cooling, fictitious mechanical cooling to be added to that to be sure that you have the thermal comfort that you assumed that you should have. And another way, of course, is to just do the ventilative cooling system and then only apply a fictitious cooling system when there are serious thermal comfort problems if you don't do that. So that was the second option in the list of options that I gave that countries have to deal with it.
Thank you. Maybe one last question for Gerard. Where do I find the information of building automation on ventilative cooling?
Yes, thank you for the question. It's not really easy. There is, like I showed this standard EN 15232, or which is now replaced by EN ISO 52120-1. And this standard, it has a pretty large sort of functional table with a lot of different building automation functions. And this is actually supposed to be used by and in the other EPB standards, especially in the standards on the technical systems. So there, but if there is really something really dedicated to ventilative cooling, I think it's not the case, or at least not the case in a comprehensive way. It might affect some like use of ventilation systems for ventilative cooling or something like that could be found there as a control option. But I suspect that it's not in a comprehensive way in the standard, and nowhere else actually. That's also one of the reasons why we make this additional document, the technical specification about the ventilative cooling.
Okay, thank you. I would close this Q&A session and this webinar. So I thank again our panelists and all the people who attended. Just a second reminder about the next webinar of the EPB Standard Series, which will take place on the 8th of September at 12. It will be entitled Heating Systems in the EPB Standards. I hope to see you all there, and thank you all.
Thank you.
Thank you.